Hi everyone, this is Katie with a random beat, on my Abacus. I have to admit that this is the first time I've ever used an Abacus. I've heard of them, I've seen them. I just honestly have never learned how they're actually used before. So as for many of you, I'm sure this week has been a learning experience for me. And I'm going to use the Abacus to show you how I would teach my 8th grade students two of the algorithms that came from the examples in our Rapid Math Tricks and Tips chapter that we were reading this week. So the first one I'm going to look at is how we would square numbers that end in 5. And my students in 8th grade do know the concept of squaring. I would start by reminding them that anytime we're squaring a number, it doesn't mean that we're multiplying it by 2. A lot of times students tend to think that. If we wanted to multiply it by 2, we would see times 2 or possibly even a 2 in parentheses next to it. But since we have an exponent of 2, we're taking the number that we're squaring and it should appear multiplied together the number of times that we see the exponent. So 25 times itself, 25. I could show the way to multiply it out, but instead of doing that, we're using the Abacus this week. So let's actually find out what the product would be before we tackle the trick that goes with it. So the first thing you would want to do, sorry, I'm trying to juggle this and get it set so you can see it. First thing I'd want to do is get 25 set up on top. And I am multiplying that by 25, and we want to separate that and put that on the bottom. Each of these represent a group of the number that I have at the bottom. Top rung here, tens and ones. Same thing on the bottom since they're separated, tens and ones. So I'm going to start with the red beads, the bottom up here, and move one for each group of the 25 on the bottom that I am moving over. So I already have one group of 25 here, so I moved one of the red beads. Another red bead would represent another 25. Now at this point I've used all of my ones on the bottom, the yellows. So 10 ones can be pushed back and replaced with one green bead, which represents 10. Continue on. So another group of 25. And another group of 25. And again, I've used all the yellows. I'm going to replace it towards the beginning again and move over another 10. At this point now I've used all of the greens, which are all of my 10s. So I put my 10s back and replace it with a 100 bead. And I am going to now move my last group of 25 from the red beads. So here is 25 more. I still have the blues to work with here. So since I've moved up a rung, I started on the red and now I'm at the blue. I'm going to move up a rung here. So instead of it being 5 and 2 10s, it's going to be 5 green beads and 2 of the white beads. So one group, 25, and another group of 25. Now at this point I only have 3 left to move, so I'm going to count off 1, 2, 3, replace them, and then put my 2 back for the 4, 5 to complete that, and then the 2 for the 2 10s. At this point I can see that I have hundreds, tens, and units, digits, or ones. So I have 1, 2, 3, 4, 5, 6. I have 2 for 620, and 1, 2, 3, 4, 5. So going back to my paper now, that tells me, based on what I see in the Abacus, that 25 times 25 should be 625. What we're told by Julius is that there's a shortcut where if we take the tens digit, which is 2, of what we are squaring, and we multiply it by the next number in order, it would be a 3. So if we take that 2 and we multiply it by the next digit, we get a 6. And we simply can just add 25 onto the end, and that would be a shortcut to squaring 25 or any number that ends in 5. So just to show you another example that was from the book, we could do 15 times 15, or 15 squared, and that would be the same as if I took the 1, the tens digit, multiplied it by the next number that would come in order, which is 2, and then I tack a 25 on the end. So this is a shortcut that Julius shows us in his 1992 book, Rapid Math Tricks and Tips. The other exercise we did this week is multiplying numbers by 11. So the example that I chose is 11 times 26. And again, I'm going to go through the sequence of actually showing how to multiply this on the abacus. And then after that, we'll talk about what the tip and the trick is that Julius gives us. So let's reset the abacus. And we have 11. So a 10 and a 1. And that is being multiplied by 26. That is 5, 6. It doesn't matter if it's 26 times 11 or 11 times 26, but this is the way the problem is set up, so we'll go this way. Again, red bead is where we're going to start, and we're taking one group of 26. Well, that group of 26 is already there, so that was easy, done for us. The next thing we'll do is move up to the blue, so we're moving up a rung, so we're also going to move up to these 2 rungs instead of the bottom 2. So another group of 26, 2, and then 6 more. And I've used all my beads from the top, so this means I'm done. My answer is 286. So based on my abacus math, 11 times 26 should be 286. The trick we're taught for this exercise this week is that if you take the number that's being multiplied by 11 and you write it with a little separation in the middle, then you can just add the 2 digits together, and that will become the number that falls in between. So again, I took the 2 and the 6 from 26, wrote it with a space in between. When I add those 2 digits up, I see that I have an 8, so my answer would be 286. That is verified from what we did on the abacus. Let's say we have a larger number, just for the sake of an example, possibly a brain builder. If we had something along the lines of, and I'll switch the order too, just to show it works either way. If we had something like 39 times 11, and we want to follow the trick, we would separate the 3 and the 9, and we're going to add 3 plus 9, but that's 12. That doesn't give us a single digit, so I wouldn't write 12 in the middle. That would not be correct in this case. I want a single digit for the middle, so instead of writing 3, 9, and a 12 in the middle, I am going to keep that 2, but then I'm going to use the 1 to carry over and put onto the 3. So instead of 3, 12, 9, I will have 429. And that would be my answer to 39 times 11. Thank you for watching my video. Sorry if it went on a little too long. I'm surprised that I was able to figure out this abacus as quickly as I did. And it's really not that bad. So looking forward to doing more of these tricks this way. Thanks.